Welcome, ladies and gentlemen, to the Free Response Question Review. In today's episode, we will be discussing the 2012 AP Calculus BC exam, question number 2. It is a particle/parametric problem, and understandably, this won't show up on your AP exam this year because of the cutback on the testing materials, but I figure it's good to go over it just so we can see how it's done. For t being greater than or equal to 0, a particle is moving along a curve so that its position at time t is x of t comma y of t. At time equals 2, the particle is at position 1 comma 5. It is known that dx dt is equal to that thing, and dy dt is equal to that thing. So before we get started, I do want to review real quick how to put these things into the calculator, because this is a calculator problem. So from here, we'll go to our trusty TI Inspire CAS, and right now I'm in F1. I'm in the F1 function real quick. Now I could do a couple of things, but I think what I'm going to do instead is I'm going to switch modes. I could actually put them in as independent functions, but instead I'm going to go ahead and put them in as a parametric function. So I'll go ahead and throw down option 3 here into my menu, which is going to go to parametric. And then from here, x1, I'm going to go and throw down, and I will go ahead and say that it's going to look like this. And after some finagling, it should look like this when you enter it in. A couple things to note real quick, I know, and some people might make this mistake. If you put the squared right here, like the way it's read in the problem, if you put the square right there, the calculator's not going to understand that. So make sure we're not putting the sign, or at least putting the squared right there. Put the squared on the outside. That way your calculator can actually read it, and we'll go and put it down like that. And so here we go. So I think once we do this, then we're ready to rock and roll with this problem. Now, this is actually going to be a pretty fast FRQ. I'm not really going to bounce back between the calculator and whatnot because this isn't really going to show up on the AP exam. As you know, they removed all parametrics from the 2020 Calc BC exam, so I'm mostly going to be setting these things up and just giving you the answer. If you have any questions or comments, of course, just leave them in the comments section, and I can show you how to use the calculator in a little bit. So the first question goes, is the horizontal movement of the particle to the left or the right at t equals 2, and then explain your answer. And then we will also find the slope of the path of the particle at time equals 2. So how do we do that? Well, when it comes to horizontal motion, that's going to be my x motion. So all I have to do is figure out the velocity of the x, which is going to be the derivative of x with respect to time. So I just have to figure out dx over dt at t equals 2. And if I just plug that in, I could use a calculator or not. I would get rad 2 plus 2 over e squared. And that would end up becoming 2 over e squared. And then from here, I would just say we're moving to the right. So the particle is moving right. In fact, I'll type this in. The particle is moving right at t equals 2 because... And then I will go ahead and handwrite the rest because I can't do fractions with the typing. And I'll just say because dx dt is positive at t equals 2. And then from here, the second part of part A is asking us to find the slope of the line, or the slope of the path of the particle at time equals 2. Now, something to keep in mind here, when they talk about the slope of the path of the particle, what this is saying is they want dy over dx at t equals 2. They want dy over dx. So remember, the slope that they're talking about is the dy over dx slope. So dy over dx at t equals 2. Well, it can be seen then that that could be dy over dt over dx over dt. Because what happens is I end up getting dy over dt times dt over dx, in which case the dt's cancel each other out, giving me dy over dx at time equals 2. And that's just done in the calculator, so once you do all that, then what you end up getting is 3.055. And again, you just plug those things into the calculator and you hit enter and you're good. Alright, part B. Find the x-coordinate of the particle's position at time equals 4. We can do that. So if I'm going to find the x-coordinates position, well, remember, up here at the top of the problem here, it tells us that at time equals 2, we have a position of 1 comma 5. So I'm going to use that as the anchor of this problem. So I'm going to integrate from 2 to 4 of x prime of t dt. because again, they're asking me for the x coordinates position. Using the first fundamental theorem, I'm going to get x of 4 minus x of 2. We know x of 2. We know x of 2 to be 1. So what that tells me is it tells me that x of 4 is equal to, after some algebraic manipulation here, I'm going to go and just plus that 1 to the other side. X of 4 will be 1 plus the integral from 2 to 4 of x prime of t dt. And then when all that's done, again, this is just calculator work. I'm just going to punch that into the calculator. I'll let you guys go ahead and do that. It's 1.253. All right, let's go and move on to part C. It says find the speed of the particle at time equals 4 and then the acceleration vector. So it's a two-parter. So speed. It's been a long time since we've talked about speed. Now, apart from being a good movie, speed is going to be the Pythagorean theorem of the velocities. So it's going to be x prime of 4 squared plus y prime of 4 squared. And that's going to get us 0.575. So this is our speed at time equals 4. Now for our acceleration at time equals 4, well, what I'm going to do is I'm going to go and find out x double prime of 4 to equal something, and then y double prime of 4 to equal something. And for that, in the calculator, again, that's just the derivative at a point option in the calculator, so I'll just go ahead and tell you guys what it is. It's negative 0.041, and then 0.989, whoops, not 988, 989. And if you wanted to write that in some type of vector notation, you would then do the hard, rather, I don't know if hard bracket, but the pointy bracket, pointy like Wendy's hamburgers, 0.989, and then you close off the bracket with another pointy Wendy's hamburger. Not like Jack in the Box where they're round. Wendy's hamburgers, you can cut your mouth on the corner of their hamburgers. Okay, part D. Part D, it says find the total distance traveled. Well, total distance traveled is very similar to speed. In fact, when we did particle motion back in Calc AB, we would do the integral of speed in order to find total distance traveled. So let's go and just write that down. So D, the integral from A to B of speed dt is going to be total distance traveled. Now you don't have to write this down as part of the answer. This is just what I know to be true. Now I know what you're thinking. You're thinking, okay, cool. From 2 to 4, absolute value of velocity, dt, equals total distance traveled. And yes, that's true. Back when we were doing particle motion in Calc AB, this is how we would find total distance traveled. Now, it's actually very likely that you could get a problem like this on your AP exam this year, because this is a non-parametric total distance traveled here. But because this question is parametric, we will not be using this version. Instead, the way we calculate speed is part of part C. So the integral, not from A, I apologize, it'll be the integral from 2 to 4 of the square root of x prime of t squared plus y prime of t squared dt. And again, that's particle total distance traveled, otherwise known as arc length. So actually, if you do parametric arc length, which actually you won't do on the AP exam because no parametrics are on the AP exam, but arc length and total distance traveled are the exact same thing. You end up getting 0.651. And I believe that will wrap it up for this FRQ. I know it was pretty fast, and that's because I didn't switch off between the calculator screen, and this non-calculator screen here. But hopefully you guys get the gist of it, and I will see you in the next episode.